Try to solve this question. Another beautiful question, sir. Find the sum of all the positive integers. Find the sum of all the positive integers such that 3n minus 4. What is the next number? 4n minus 5. 4n minus 5 and 5n minus 3. Find the sum of all the positive integers for which 3n minus 4, 4n minus 5, 5n minus 3 all are prime numbers. All are prime numbers. Find the sum of all the positive integers such that all these are prime numbers. All these are prime numbers. Case number 1. Case number 1. N is an even number. If I take an even number, 3n minus 4, 3n minus 4, even into even, minus 4 is an even number. Even minus even, it is an even number. Even minus even, it is an even number. What is the 3n minus 4 should be prime. And it is saying it is an even number. So the only possibility is 2. There cannot be any other prime numbers other than 2 which is prime. 3n minus 4 equivalent to 2. 3n equivalent to 6. n equivalent to 2. n equivalent to 2. These n value 2 should make the other two numbers prime numbers. So these 4 into 2 minus 5, 8 minus 5, 3. Yes, 4n minus 5, it is a prime number. 5 into 2 minus 3, 10 minus 3, 7. It is a prime number. Prime number. N equivalent to 2. N equivalent to 2 has made 3 into 2 minus 4, 6 minus 4, 2. Prime number. Prime number. 4n minus 5, 4n minus 5, 8 minus 5, 3, 5 into 2 minus 3, 7. Case n, 3n minus 4. It is an even number. Suppose if 4n minus 5 it is, what will happen? Let us see. 4n minus 5. 4n minus 5 it will become. If n is even, even into even, even into even. 5 it is nothing but an odd number. Even minus odd, it is an odd number. Even minus odd, it is an odd number. I hope the idea it is clear. 4n minus 5, even minus odd, it is an odd number. Let us take some. 4n minus 5, it is 3. 4n equivalent to 8. n value, it is 2. The same thing we got. If it is 4n minus 5, 4n equivalent to 10. n is a decimal, not possible. 4n minus 5, 7. 4n equivalent to 12. n equivalent to 3. n equivalent to 3 if I substitute this value. 5 into 4n equivalent to 12. 4n equivalent to 12. n equivalent to 3. If I substitute, this will become 5 into 3 minus 3. 15 minus 3, 12. 12, it is a composite number. I hope the idea it is clear. Similarly, 5n minus 3, it is an, what it will become? n is even. Even minus odd, it is an odd number. It is an odd number. What are all the odd numbers? Odd numbers will be odd prime, right? 3, 5, 7, 11, 13 and so on. 5n minus 3, it is 3. n value 6 by 5. Fraction not possible. 5n minus 3, it is 5. 5n equivalent to 8. Not possible. 5n minus 3, 7. 5n equivalent to 10. n value, it is 2. n value, it is 2. That is what we did it. n value 2. 3 into 2 minus 4. 4 into 2 minus 5. 5 into 2 minus 3. Any other value? Let us see. Suppose if I take 17, 5n minus 3, 17, 5n is 20, n value 4. If n value, if it is 4, 5n minus 3, 17, n value 4, 12 minus 4, 8, 8 is a composite number, not possible. So these n equivalent to 2 I got. Case number 2. Case number 2, n is an odd number. n is an odd number. Two cases are possible because n is a positive integer. N can be even or n can be odd. If n is an odd number, 3n minus 4, odd into odd, odd, minus 4, 4 is an even number. Odd minus even, it is odd. Let us see, 4n minus 5. 4n minus 5, odd into even, it is even, minus 5. 5 is an odd number. Even minus odd, it is an odd number. 5n minus 3. 5n minus 3, odd into odd, odd, minus 3. 3, it is an odd number. Odd minus odd, it is an even number. Only one case possible. 5n minus 3 is equivalent to 2. 5n equivalent to 5. N equivalent to 1. But if I take n equivalent to 1, 4 into 1 minus 5. 4 into 1 minus 5. 4 minus 5. 4 minus 5, it is a negative number. That means case 2, case 2, n odd number, this case not possible. Again I am explaining. We are doing two cases where all the three are prime. Case 1 is when n is an even number. Case 2 is where n is an odd number. Case number 2, it is not possible. Odd minus even, it is odd. Even minus odd, it is odd. 5n minus 3, it is even. Only even number is 2. 5n is 5. N value 1. If n value 1, 4 minus 5, it is an odd number. So case 1, case 2, n odd number not possible. Case number 1, in n even number, what all values that are possible, that values please check it out. Which all values it is possible? Here 3n minus 4, it is even. N value 3n is 6, n equivalent to 2. One value we got. 4n minus 5, it is 7. N value 3. Another 3 value we got. 5n minus 3, it is 17. 5n is 20. N value, another we got. What are all the values? N values. Add it, that you will get the answer. N values, whatever the values that you get it. 5n minus 3 is 17. 5n is 20. N is 4. 4 is not substituting. Not satisfying. 5n minus 3, it is 7. N is 2. To check it out whether it is satisfying. Clearly for me, n3. n3 also is not satisfying. Clearly 2, 3 and 7 are visible to me. So 2 plus 3 plus 7. Answer is 12. Idea clear? Nothing you have to do in this question. Put n value even number, n value odd number, such that this triplet should be a prime number. Triplet should be a prime number. Next one. Let x and y are positive integers such that x is a prime number. If it is a prime number, the series will be like this. 2, 3, 5, 7, 11 and so on. And y is a composite number. Composite number will be any number which has got greater than 2 factors. So it can be 4, 6, 9, 15, 8 and so on. Okay. X is a prime number, y is a composite number. Y minus x cannot be an even integer. First one. Y minus x cannot be an even integer. If I take 4, x has 2. 4 minus 2, it is 2. It can be even. X is a prime number. Prime number can have an even prime number or an odd prime number. Composite number can be even. Composite number can be an even number or an odd number. Even minus even is even. From this case you will get it. Or if x is an odd prime number, y is a composite number, these also can give you the answer. 9 minus 3. So first option is definitely incorrect. First option is definitely incorrect. X and y cannot be an integer. X and y cannot be an integer. X is a prime number. It can be an even prime or it can be an odd prime. Y is a composite number. Either it can be an even number or it can be an odd number. So if I take even into even into odd even, these also not possible. These also not possible. X plus y by x. X plus y by x. which is nothing but 1 plus y by x, cannot be an even number. Cannot be an even number. Suppose, for example, y is 9 and x is 3. 1 plus 9 by 3. 1 plus 9 by 3. What is 1 plus 3? 1 plus 3, 4. It can be an even number. So all three are incorrect. The answer is none of them is true. It's a simple definition of a prime number and a composite number. Prime number and a composite number. Prime will have even prime number and an odd prime number. Composite number also, there can be an even numbers, there can be an odd numbers. There can be an even numbers, there can be an odd numbers. Next one. Let n be a composite integer. Let n be a composite integer such that root n is not an integer. So let me take a non-perfect square. N equivalent to 12. Root 12 is not an integer. Root 12 is not an integer. Okay. First thing, I just took a value which satisfies the statements. Now what are the factors of 12? Factors of 12 are 1, 2, 3, 4, 6, 12. Okay. N has a perfect integer valued divisor which is greater than 1 and less than root n. That means he is saying n is 12 here. Read the statement, sir, you will understand. N has a perfect integer valued divisor. This 12 has a factor. That factor is greater than 1 and less than root 12. So he is telling greater than 1, less than root 12, there is a number, it seems, there is a number x that will perfectly divide. It will perfectly divide the number. Is there a factor? Greater than 12. Greater than 12 lies between greater than 9 and greater than 16. There is a number from 1 to root 12 which will perfectly divide 12. Definitely yes. 2 lies from 1 to root 12. Does 2 divide 12? Definitely yes. 3 lies from 1 to root 12. Does 3 divide 12? Perfectly yes. First statement is perfectly right. Next statement, n has a perfect integer value which is greater than root n and less than n. There is a number, it seems, which is greater than root 12 and less than 12. Is there a number 4? Does 4 divide 12? Definitely yes. Not only 4, 6 also will divide 12. So both the statements are perfectly right. Both the statements are perfectly right. Why both the statements are perfectly right? I took n equivalent to 12. Factors of 12 are 1, 2, 3, 4, 6 and 12. These are the factors of 12. 3 is root 9. 4 is root 16. Between these value, there is a value root 12. Are you all with me? Between these two values, there is a value root 12. Now see here. From 1 to root 12, are there any numbers? Yes. There are two numbers, 2 and 3, which will divide 12. 2 6 are 12, 3 4s are 12. Between or from root 12 to 12, are there any numbers which will divide 12? Yes. 4 will divide 12, 6 will divide 12. Both of them are true. This is a CAT original question, sir. Next is a CAT original question. Please read the question. CAT original question. Read the question. Number of employees in an Oblix Menhir company. There is a company by name Oblix Menhir company. Number of employees, it is a prime number. Okay. The total number of employees in this company, it is a prime number and it is less than 300. First statement is clear. The ratio of the number of employees who are graduates and about to that of employees who are not can possibly be. There is a company and in that company there are employees. There are two kinds of employees. employees who have done graduation, employees who have not done graduation. The sum of these two employees who got graduated and the employees who did not got graduated, sum should be a prime number. Sum should be a prime number. So if I take sum 101 plus 88, 189, 189, 189, 189. This is 100 plus 87, which is 187. This is 110 plus 98, 208. It is 85 plus 98, 183. This is 97 plus 84, which is 181. Out of these 5, one number is possibly a prime number because it is a ratio. The numbers could be the multiples of the given values. 189, it is divisible by 3. Definitely it is a composite number. 9 plus 1 plus 8, 10 plus 8, 18. 18 is divisible by 3. 183, it is also divisible by 3. 1 plus 8, 9, 9 plus 3, 12. 187, sum of the odd places 8, even places also 8. Sum of the odd places. Sum of the odd places equivalent to sum of the even places. Sum of odd places equivalent to sum of even places. It is divisible by 11. It is divisible by 11. This is not possible. 208, it is an even number. Other than 2, there is no even number which is a prime number. Not possible. Answer is 181. So answer for this question is a option number 5, which is 181. Very, very easy question. There is a company which has got employees who got graduated, and the employees who did not got graduated. So we have to check which of the following is a prime number. Very, very easy question, cat question. Next one. Next question. Read this question. Again it is a cat question, sir. Again it is a cat question. Cat question. Read the question first. The smallest positive value. We require an lowest value for x, for which the fraction is x plus 2 by 10, x plus 13 by 11, x plus 26 by 12, x plus 2002 by 50, x plus 2002 by 50. All these fractions should be in its simplest form. What do you mean by simplest form? A by B. A by B should be in its simplest form only when A and B are co-prime to each other. Only when A and B are co-prime to each other. When they will be co-prime to each other? When their HCF is 1. When their HCF is 1, HCF of numerator and denominator should be 1. Then the numbers are said to be co-prime to each other. A and B are said to be in its simplest form. Simplest form when the HCF it is 1. 1 by 7, simplest form. 3 by 13, simplest form. 8 by 12, not in a simplest form. 4 2s are 8, 4 3s are 12. Not in a simplest form. Not in a simplest form. I hope the idea it is clear. Now let us see if I can eliminate some answer options. By looking at a question, I can eliminate 53. Why? Because 53 plus 2 is 55. 55 by 10. 55 is divisible by 5. 10 is divisible by 5. This is not possible. Second one out. Fourth one out. Second also it is out. Why? Because 49 plus 26, 75 by 12. 75 by 12, it is not in its simplest form. Both are divisible by 3. Now if you see here, now can I write this equation as x plus 2 by 10? x plus 2 by 11 plus 1. Can I write? 11 ones are 11, 11 plus 2, 13. This is x plus 2 by 12 plus 2. Are you all with me? 12 twos are 24 plus 2, 26. X plus 2 by 50 plus 40. 50 40s are 2000, 2000 plus 2, 2002. 24 plus 2, 26. 11 plus 2, 13. Now if you see, for the equation should be in its simplest form. For the equation should be in its simplest form. These numbers should be co-prime to each other. Yes or no? These numbers should be co-prime to each other. That means x plus 2 cannot take 10, 11, 12 and so on up to 50 are factors of or multiples of 10, 11, 12 till 50. I hope it is clear. If x plus 2 takes 10, 10 by 10, 10 by 10 it is not in its simplest form. If x plus 2 takes 11, 11 by 11 it is not in its simplest form. 12 by 12 not in its simplest form. Are factors of 10. Let me take a factor of 10 2. 2 by 10, it is not in its simplest form. Are multiples of 10. If I take 20, 20 by 10, not in its simplest form. So x cannot take 10 minus 2, 8, 11 minus 2, 9, 50 minus 2, 48. Here 49 also will come, 47. X cannot take 47. So the only case possible is 51. Very, very easy question. Only case possibility is 51. This is a new question where the fractions are in its simplest form. If the fraction is said to be in its simplest form, that means numerator and denominator are co-prime to each other. If numerator and denominator are co-prime to each other, their HCF it is 1. 1 is I eliminated by using answer options. 53 plus 2, 55 by 10. It is not in its simplest form. 49 plus 26, 75 by 12. It is not in its simplest form. Option 4 and option 2 are eliminated. Then I expanded this fraction by x plus 2 by 10, x plus 2 by 11 plus 1. So x plus 2 cannot take 10, are factors of 10, are multiples of 10. X plus 2 cannot take 11, are factors of 11, are multiples of 11. From this, if you expand it, x plus 2 cannot take 49, 50. X cannot take 47. First option is also eliminated. We are discussing the